It's an absolutely fabulous question. So we had several iterations of this. So it's a very good question, high quality question. So if you've not tried this question, hit pause on this video. You're going to get tons of value, especially in the idea of permutation, combination, probability particularly, by trying to solve this question and not just listening to this video. So please hit pause, try this, give this question a shot, give it some time, then come back and see this. And lovely. A man is known to speak the truth on an average 4 out of 5 times. Should be in politics. He throws a die and reports that it is a 5. The probability that it's actually a 5 is brilliant. It's a classic question where he has reported it as a 5 and you have to find a probability that it is a 5. And it's conditional probability, but the other way around. Given it is a 5, what is the probability that he'll report a 5? That is 4 by 5. If it is 5, it's a 4 out of 5 chance that he speaks the truth. That is clear. He has said it is 5. What is the probability that it actually is 5? That's what we're trying to do. And so we're going to use Bayes' theorem. Very interesting, very straightforward, not a really straightforward idea, but an intuitive idea. And so what is Bayes' theorem about? It's step-by-step conditional probability. And so A happens, there is a probability of A happening, probability of A not happening. If A happens, there's 2 events. If A does not happen, the same 2 events. And then we go step by step. Given that the ball is turning, what is the chance that India will win? Given that the ball is not turning, what is the chance that India will win? What is the chance of India winning overall? Given that India has won, what is the probability that the ball did turn? Those are the different types of questions you can get in this. Fine. So the standard framework for this is, don't worry about the post facto probability. Given that he reports a 5, what is the probability that it was actually 5? Forget that. Think about it in a chronological order. He rolls a die. It could be a 5. It need not be a 5. So let's start with that. So our man rolls a die. It could be a 5. It may not be a 5 or not a 5. So not 5. Given a 5, here he reports 5, reports something else, or reports not 5, does not report 5, reports 5, reports not 5. And then we'll carve out this entire probability and then go back to the reverse conditional aspect of it. Right? Given that it's a 5, what is the probability that he reports a 5? 4 by 5. What is the probability he reports something else? 1 by 5. What is the probability of it being a 5? He rolls a die. All this reporting, not reporting nonsense is not there. He rolls a die. What is the probability of it being a 5? 1 by 6. What is the probability of it not being a 5? 5 by 6. And then it is methodical. It is a 5. What is the probability he reports a 5? 4 by 5. Given it's a 5, what is the probability he reports something else? Does not report it's a 5. This is 4 by 5. This should be 1 by 5. It's not a 5. The probability that he reports 5 means he's lying, not speaking the truth. 1 by 5. It's not a 5. He reports not 5. 4 by 5. Right? So this is the structure that you'll have to use for these questions. An event is rolling a die. 5, not 5. Then comes the reporting part. Reporting as 5, reporting not 5. Reporting as 5, reporting not 5. What are the possibilities? It lands on 5, he reports 5. He lands on 5, it does not report 5. It does not land on 5, he reports a 5. It does not land on 5, he reports not 5. That means each of these strands, what is the probability of this occurring? Is going to be 1 by 6 into 4 by 5. Of this occurring, 1 by 6 into 1 by 5. Of this occurring, 1 by 5 into 5 by 6. Of this occurring, 5 by 6 into 4 by 5. Now if you just want to check, this 1 by 6 into 4 by 5, 4 by 30. 1 by 6 into 1 by 5, 1 by 30. 1 by 5 into 5 by 6, 5 by 30. 5 by 6 into 4 by 5, 20 by 30. I'm keeping not cancelling, I'm just keeping the denominator as 30. You think about it, this is 20 by 30. This is 5 by 30. 1 by 30. 4 by 30. Lovely. So 4 by 30 plus 1 by 30, 5 by 30 plus 5 by 30, 10 by 30 plus 20 by 30, 1. These trends, these are the sum total of all possibilities, they all add up to 1. we have not been asked what is the probability that it turns out to be 5 and he reports a 5. That is simple. Multiply this and get this. We have not been asked that. We have been told clearly that he reports a 5, and then we have been asked what is the chance that it actually was a 5. That means the event that has happened is the fact that he has reported a 5. That means the event is either taken this path, it is 5 and he reports 5, or it is not a 5 and then he reports a 5. One of these two has happened. That means this and this are ruled out. They simply didn't happen. The question is not saying what is the probability that you will reach this point. The question is saying what is the, given that you have reached that point, what is the probability that you took this path? Brilliant. So given that you have reached that final point, that is, you have reported that it is a 5. That is, it is either 4 by 30 or 5 by 30. One of these two has happened. What is the probability that you came by this route? Think about it. Just the numbers are very friendly. Either you took this path to reach that, or you took this path to reach that. You finally reached the destination. What is the probability that you took the first part? So the destination has been reached, or your denominator is 4 by 30 plus 5 by 30. Numerator is 4 by 30. You're done. I'm going to just do the numbers all over again. 1 6, 4 by 5, 1 by 5, 5 6, 1 by 5, 4 by 5. 1 by 6 into 4 by 5, 1 by 6 into 1 by 5, 5 by 6 into 1 by 5, 5 by 6 into 4 by 5. Probability, this 2 by 15 divided by this 2 by 15 plus this 1 by 6. 2 by 15 by 2 by 15 plus 1 by 6, or 4 by 30 by 9 by 30, 4 by 9. Beautiful, delightful question. If only this question were as beautiful as just this. This question is brilliant. This question is beautiful because it is not this simple. This looks simple. Let me rephrase it. This doesn't look simple. Standalone, this question is still nice, but we have missed one big chunk. Right? So the answer, surprising as it may, we've got 4 by 9. It's available in the answer choice. Probably is not right. Right? So what are we missing? What is something that we perhaps are not getting right? Think about it. We have thought about this and structured it as getting a 5, reporting 5, not reporting 5. Not getting a 5, reporting 5, not reporting 5. And not getting a 5, reporting the correct one, the chance is 4 by 5. Reporting the wrong one, choice is 1, probability is 1 by 5. The correct one is not reporting 5. That's correct. The wrong one is just not right. It doesn't mean it has to be 5. This part is tricky. Think about this. Suppose I get a 4. The probability of reporting 4 is 4 by 5. Good. Probability of not reporting 4 is 1 by 5. Reporting 4, not reporting 4. Exactly complementary events adding up to 1. Good. Probability of reporting 4 is 4 by 5. Not reporting 4 is 1 by 5. Not reporting 4 is not the same as reporting 5. Very crucial point there. Right? So if you're not getting 5, probability is 5 by 6. Reporting correctly, that will be 4 by 5. Reporting incorrectly, that will be 1 by 5. Right? But reporting correctly is not exactly same as not reporting 5. Reporting incorrectly is not exactly same as reporting 5. If I put a 4 and I report 3, I am still incorrectly reporting, but I am not reporting a 5. Fine, so that part is very crucial. So I'm going to dive deeper into that. We are not getting a 5, but say we get a 4. There's a 5 by 6 probability of that happening. That is not 5. We're thinking about only 4, it is 1 by 6. But I'm considering the not 5 category, taking one specific instance of it being 4. Right? I report a 4, that's a 4 by 5. That is easy part. I'm not reporting 4, that is 1 by 5. Good, wonderful. In this, if I'm not reporting 4, I'm reporting 1, 2, 3, 5 or 6. Within this, I could be reporting a 5 or I could be not reporting a 5. 1, 2, 3, 6. And reporting 5 probability is 1 by 5. Not reporting 5 probability is 4 by 5. Or in this 1 by 5, we multiply with this 1 by 5 to get 1 by 25. This 1 by 5 into 4 by 5, we get 4 by 25. Now we come back to our original breakdown and say, not getting 5 is 5 by 6. Reporting it as a 5 is 1 by 25. Not reporting as a 5 is 24 by 25. Why? Suppose this were a 4. I'll report it as a 4 in 4 out of 5 turns. I'll report it as 1, 2, 3 or 6 as 4 by 25. Reporting as 5 is only 1 by 25. 4 by 25 plus 4 by 5 is 24 by 25. This part is not just 4 by 5. It's the most important part. You get a 4, reporting as 4, there's a 4 by 5 chance. Reporting not 5, there's a 24 by 25 chance. You could report incorrectly. You could report it not as 4, but as 1, 2, 3 or 6. That is still possible. That has to get accounted for here. After this, we are back to base theorem. How so? We're back to the same probability. This is 5 by 6 into 1 by 25. This is 1 by 6 into 4 by 5. This is 2 by 15. This is 1 by 30. And the final probability we have will be 2 by 15 by 2 by 15 plus 1 by 30, or 4 by 30 by 4 by 30 plus 1 by 30, 4 by 30 by 5 by 30, which is 4 by 5, which seems intuitively right. If he reports a 5, the probability there is actually a 5, he speaks truth 4 out of 5 times, it should be roughly in that ballpark. It's correct. Unfortunately, the exam, that choice was not available. So I don't know what they would have done. I don't know whether they fixed it. I don't know what they did with it, but that's all incidental. The key point here is this question. If you're not reporting 5, that does not mean, that is not the same as getting it wrong. When you're not reporting 5, could mean you're reporting 1, 2, 3, 4 or 6. It could be 4, in which case you're getting it right. 1, 2, 3, 6, wrong, but not 5. So there's that caveat, that one little bit thing that you still need to worry about. That's what makes this question not just good or great, but magically good. So beautiful question. There's tons of value in just going through this question and saying, oh yeah, lovely question. So please do that. Take that value. Best wishes for the exam.